So in Chapter 9, we were talking about properties last time. A property is cool because it gives you what looks like a variable, but with a getter and a setter. And so the way those look is like this. We have a variable named ID number, and then we put this very particular syntax, public ID, ID number, same thing except with an uppercase I rather than lowercase, open brace, closing brace, and inside there we have a getter, different syntax, there's no parentheses or anything, and then we have a setter. And so the point of doing that is that you have a variable, it's made private, and you have getters and setters for it, and if they need to do any data validation or calculations, they can do so. You could have a get area that would perform the, calculate and return the area. It doesn't even have to reflect. It doesn't even have to expose a private variable. It could just do, a calculation of a variable. So like, are we on V or U? I think we're on U. I believe that to be the case. All right. So I'm going to make a new C# application, Lecture U.
Actually, we already have a U.
We already have a U?
Yep.
Do we have a V?
Yes. That was the optional one.
So we're W?
Yep.
All right. Okay.
You know what I mean? He's finished up that alphabet.
My most recent projects list is faking me out here. Okay. So suppose we add a class called Circle. It had one instance variable, which is an int, public int radius. And what we wanted to be able to do was something like this. Circle C1 equals new circle C1.radius, and yes, it should be made a setter or something like that, equals 10. And then once we have that, I'd like to be able to do this. Int or double area equals C1.area, like that. Although with the capital A there. And without the curly braces. Now I'm not really convinced that I like this syntax here. And what do I mean by that? We are real used to having calculations performed in methods, right? Like that. Not just inside properties. Well, let's just run with it. Double area, and it's going to have a getter, but no setter. So get, and what does it return? It returns 2 times pi times r. So return 2 times, how do I get a hold of pi? Math.pi times radius. That's not right, that's the circumference. Math.pi times radius, pi r squared. All right, this would be a valid way of structuring the program. We've implemented a read-only property called area that whenever we access, it calculates. You gonna go away now? Are you happy with what I've done here? Oh, I forgot to make it public. Excuse me. Public double area. Like that. Trying to squeeze it onto one page and failing to do so. Alright, like that. The circle class has an instance member, which ought to be a double as well, really. And it has a property called area. It's a read-only property, so it's got a get. So when you want to access it, you just do it just like it was a variable. But if you try to change that, if you tried to do C1 dot area equals 10, that'd be a syntax error because there's no setter. We did not implement a setter for it. We only implemented a getter. And like I said, that's a valid way of coding it. I'm not really sure I would. I'd rather see a method called getArea, right? But that's a valid way of doing it. How about auto-implementing properties? As we saw in the last one, you can create a variable and you could expose it with a getter and a setter. Let's do that for this radius variable. Apparently I'm going to keep it as an int. No, I'm going to change it to a double. So this is the hidden variable, so I'm going to change public int radius to private, and since double would be a better type for it, I'm going to make that change. Private double radius, and then I'm going to implement a getter and a setter for it. The property will be called the same thing with a capital R. Public double radius with a capital R, curly brace, get, curly brace, return radius, or this dot radius, and then sets radius equal to value. So we've implemented a radius property which exposes this private instance member there. Now again, why would you do that? Because the getter and the setter may become more complicated at a later point, right? The value of this may be stored on disk rather than in memory. Or maybe we want to ensure that there's no such thing as a negative radius, so we could have an if statement in here, so that when we were trying to set it to a value, if we tried to set it to a negative value, it threw an exception, or set the radius equal to 1, or something like that. Trying to keep our object in a valid state. I'm going to leave it alone, but that's what if I was going to give an example of doing something useful with the setter, I would go ahead and make it check right here. Make sure that radius is not a negative value. Now that broke our code down here because our code down in main is trying to access radius with a lowercase r. So I'm going to have to scroll down to main and fix that to be radius with an uppercase r. And if you like to compact up these getters and setters to one line, you can. I'm kind of fond of doing that. I like the way it looks on the screen. If it's only one line of code, why not do it that way? That's my opinion. And so down here inside main, as I mentioned, since radius with a lowercase r is private, we're going to access the property instead, radius with an uppercase r. All right. So the next thing we're going to do is an auto-implemented property. What is an auto-implemented property? An auto-implemented property is one where you don't actually have to declare a variable behind the scenes. And so you don't have to write this line of code, and you don't have to write this line of code. So the syntax is really super duper clean. Looks like this. I don't know what we're going to call this variable. The color of the circle. Private string color. And it's a property, so it needs the curly braces, and it needs a getter, and it needs a setter. And if you want to initialize it, you could. You know, circles by default are black. Now that looks really weird. Oh, well. Oh, I forgot the semicolon. Still not liking that. What's the error? Invalid token equals sign. Well, my example is showing it. For one thing, I should have made this public because it's a property. There's no reason to make it a private property. It's still not liking that, so I'm going to flip back to the PowerPoint and see what I'm doing wrong. It's not going to show us. Auto-implemented property. Auto-implemented property are called automatic properties. The implementation is created for you automatically with the assumption that the set should just set a value and the get should just return the field. So you do not need to declare the field. You do not need to declare the lowercase letter version of it. And here's our example of it. ID number, get and set. Apparently the example that I'm looking at where you can give it a default value is incorrect. So I'm going to go and remove that default value here. It's not correct. All right. And then down in main, we could set the color because it's got a getter and a setter. Now, why would you want to do it that way? Because later on, you might want to make this a little bit more complicated. You might want to make a private variable called lowercase color and the getter and the setter do some kind of validation on it to make sure that it's a valid color. So it's a really fast way of creating variables that you can later on go and make the private fields and then have the public properties expose them. So it's just setting it up for later goodness. I am sure that I've scrolled up and down way too many times. So I will scroll down slowly. You can look at it and then I'll walk about the classroom. All right, so our class circle goes from here all the way down to here with one more closing brace. And then here's our main. Let's make it set the color even though we're not doing anything with it. C1.color equals orange. All right, so for the other people in the classroom, it was working to have a default value for the color. And the reason why is I'm just running an old version. I'm running, Visual Studio 2012 or whatever, and y'all are on 2019 or whatever. So y'all would be able to do this, right? You would be able to do that if you're not using a school computer. That would work. Doesn't work here, so I'm deleting it, or at least commenting it out. Nah, deleting it completely. Okay. So that's properties. Properties are useful. It does not take much time to type it like this. It satisfies the requirement of having your data encapsulated, and later on you could go and you could expand it to something like this if you needed to. If you needed the getter and the setter to do data validation. So I strongly recommend that from here on out, if you're going to use variables and you want them to be accessible to the calling code, that you go ahead and implement them as properties rather than as instance variables. So access modifiers. The methods are usually declared as public. The fields are usually declared as private. The properties are usually made public. You can create a public data field if you want, when you want all objects of a class to contain the same value. All right. And a named constant within a class is always static. It belongs to the entire class. So the next thing I wanted to touch upon is the idea of inheritance. With inheritance, we could create something that your class has to either is or has to implement. Like a circle is a shape and a rectangle is a shape. So our circle here, we're probably going to wind up getting rid of that area thing, or we're going to make some other examples that have a get area method. So I'm going to make an interface. and call it shape. And it can have data. I'm thinking about not even putting any data in it for the ease of implementation. But we can specify the members that the classes that inherit will have. And so how about get area? Every shape has to have a get area method. So public double get area. But we're not actually providing a body for it. But when we make a rectangle class and a triangle class and a square class, those will also have a get area method. They will provide the body for it. Let's call this shape 2D, capital S, shape 2D. It's a two-dimensional shape, so it has an area. And let's make another interface called shape 3D, which has a get volume. Public double get volume. Now I'm going to make a rectangle and I'm going to make a block. Or how about just a square and a cube? Those are easy, right? So a square inherits from the shape 2D and this all goes above, by the way. Apparently I'm putting all my stuff above the namespace declarator. I should have put it inside the namespace declarator, but it doesn't really matter as long as these are all going in the same place. Okay. And for it to compile, since we're saying, oh, by the way, this is a 2D shape, it has to have a get area method. So when I try to compile it, it should throw out an error in the error list. Yep. Well, the modifier public is not valid. Wonder why. Okay, fine. We'll make it not public. Alrighty, and then down here we are going to that's a difference in Java, by the way, and C#, is that in Java you declare these with the same access that you're going to do it where you actually provide the body for the code. So 2D shape, if it's a square, why don't we create a constructor that'll set the sides of the square? So public space square with a capital S, parentheses, double side, and we will just say that this dot side equals side. And if we're going to do that, we have to have a side variable. So up above the constructor, private double side. So that's the constructor for it, but it also needs, if I build it, I better get the error message that I'm expecting. Square does not implement interface member. So when we do this, we're saying, I'm inheriting from shape 2D. I am a 2D shape. This is saying, oh yeah, you think you're a 2D shape? Well, you better have a get area method. Let's do it. So down here, public double get area, parentheses and parentheses, and the area of a square is just side times side. So return side times side, or this dot side times this dot side, if you prefer to do it that way. All right, and that build succeeded. So we have successfully created something that is a 2D shape. Now we're going to make a cube. And we're going to say that a cube is both a 2D shape and a 3D shape. Now the surface area of a cube is calculated as 6 times side times side. because this cube has 6 sides. So it is going to have a get area method, but it's going to return 6 times side, and it's also going to have a volume, which is return side times side times side, right? Because that's the volume of a cube, is its edge times edge times edge, or edge cubed. So public cube colon, it is a shape 2D, comma, and it is a shape 3D.
Is it public cube or class cube?
You're right, it's class cube. My mistake. Where was my brain? All right. Again, it needs a variable side length or edge length. So private double side. If we were really awesome, we would implement that as a property. Would it take much time to do it? No, not at all. We just have to do this. Get semicolon, set semicolon there. It's a property. And if we're going to do that, we should make it an uppercase S, just by convention. I'm not going to change the other one because I'd have to change some uppercase S's. Don't feel like it. Alrighty, now for the constructor of the cube. Constructor is a method that has the same name as the class itself. So public cube, and it's going to take a double side as its parameter variable. And it sets this dot side equal to side. All right, since it's a 2D shape, I'd better implement get area, and since it's a 3D shape, I'd better implement get volume. It will not compile until I have those two. So let's implement get area, public double get area, which returns 6 times side times side. Capital S's now because it's a property. Don't forget the semicolon there, or else it won't compile if you're doing my silly single line syntax. And I don't know why I put an S on returns. That's silly. There we go. And get volume is going to just return side times side times side. Public double get volume, parentheses and parentheses, return side times side times side. And usually I would use this reference, but it's actually more typing when the variable is that short of a name, or the property. And again, all uppercase S's because I implement it as a property. Now I'm not getting 2 references here. This method has 2 references. Double get area. Oh, okay, because one place get area is defined is inside the shape 2D definition. We can see that over here. And the other place that this get area method is defined is inside this class itself. So if I was going to add a comment, I would say, because I am a shape 2D. And I'd probably add the same thing here. I mean, normally I wouldn't, but to make it real clear right now, because I am a shape 3D. That's not the only kind of inheritance. The syntax for the other kind of inheritance is the same. It's just that if we were going to do the other kind of inheritance, let me scroll up a little bit, we wouldn't put the word interface here. We would put the word class. And when we implemented a method, we'd actually go ahead and provide a body for it. I think down in main, I'm going to go ahead and create a square and a cube and get their area and their volume just for giggles.
So square S1 equals new square with an edge length of 10, and cube C1 equals new cube 10.
And int AR for area and VO for VOL for volume. AR equals S1 dot get area. AR equals C1 dot get area.
I forgot my equal sign. And then volume is equal to, and I seem to be getting some kind of error here. I'll have to figure out why as soon as I'm done typing this. Is C1 dot get volume. All right, what's up with you? Cannot convert a double to an int.
Oh, okay, but that's because all my return types are double. So not int AR volume.
Double AR comma volume.
And yeah, I can print them out and whatever. I'm pretty confident that they work at this point, so I'm not going to bother. So inheritance implements a is-a relationship. A square is a 2D shape. A cube is a 2D shape, or it is a 3D shape. Whereas what we've been doing before is has-a relationship. Every circle has a side length. Or every square or every cube has a side length. Every circle has a relationship. So you have has-a versus is-a. And is-a is implemented by inheritance.
We have a little bit of time left. We may as well do one more
Classic inheritance rather than doing it as an interface. Now the thing about classic inheritance is that if you inherit from a class rather than an interface, you can only inherit from one class. That's a difference from C++, but it's exactly the same in Java. On the other hand, if you declare your things as interfaces, you can implement as many different interfaces as you want. So the interfaces get you around the fact that you can only inherit from one class. Okay, so we're going to make a class called animal. It's going to have only one method called eat, and then we're going to declare another class that inherits from that class.
So class animal, public void eat, parentheses in parentheses, SW tab tab, no wait, CW tab tab, I am eating. And we're going to make a cat, which is an animal. Oh, and look at that. I'm getting an error here. A new line and a constant. Okay, I forgot my double quotes. Sloppy. Cats are animals. So we're going to use the
colon syntax. And by the way, the colon represents the same thing that Java uses the extends keyword if you've done Java. However, the colon also means what Java calls the implements keyword. And you just mix and match them, right? Anything after the colon implements or represents either an extension of a class, an inheritance of a class, or an implementation of a class, indistinguishably. Okay, so a cat class.
Class cat, but a cat is an animal. So public void, what do cats do that are different from animals? They meow. CW tab tab, and when you call meow, it meows. And we may as well make another animal called dog. Class dog is also an animal. Or how about we make something else that is a cat? A tiger that is a cat. Class tiger, colon, which is a cat. And so all cats can eat. So all tigers can eat. All cats can meow. So tigers can meow. Let's just roll with it. I don't really know of any meowing tigers, but let's just go with it. And so public void roar. Lowercase roar. Because tigers can roar, whereas kitty cats cannot. CW tab quote roar end quote in parentheses semicolon. So this is a hierarchy, an inheritance hierarchy. The superclass, the base class, the root class is animal. Cat inherits from animal. To use Java terminology, it extends. So it is the child class. It is the subclass of animal. And then a tiger is a cat, so it inherits from a cat, which inherits from animals. So at each point, it gets another capability. The animal is the most primitive type, and the only things that should go in the animal class are things that are common to all animals. And the only thing that should go to cats are the things that are common to all cats. And the only thing that should go to tiger, if tiger is a very specific kind of animal. So realistically, would I have actually implemented a tiger as being able to meow? Probably not. But what should I have done? I should have made a feline class, and then a cat class that extends feline, and a tiger that extends feline. And the cat class, if you call make a sound, could call meow. And the tiger class, if you called make a sound, could do roar. But I think this is clear enough. Alright, when adding stuff, I've broken namespace. I must have too many closed braces or not enough. Yes, I do. That's correct. On the cat class, I forgot to close my class completely. If I was being a good programmer, I would have put end cat class, and I would put end tiger class. And then down here, this is what we added to test our spheres and stuff. Ooh, look at that. More errors still. Cannot implicitly convert a circle to a cube. Well, I guess that's true. I forgot to make a new cube.
No, they're both named C1.
Because I already have a variable named C1. Okay. So, I'm going to call this cube1. And then call this cube1. And call this cube1. And that should make all the errors go away. And we didn't create any tigers or lions or anything, so we may as well tack those on as well. Or lions? I didn't make any lions. Cat, kitty equals new cat, kitty.meow. And he can also eat, because all animals can eat. But he cannot roar. The tiger can. Tiger. Fred, can't think of a good name. Wait, Tony. Tony the tiger. Yeah, breakfast cereal is equal to new tiger. Tony can eat. Tony can meow. Never heard him do it, but apparently he can. And Tony can roar. Okay, I was wrong. Just because it said the final, okay. Final exams begin on Wednesday and last until Tuesday of the following week. So, I'm hoping everybody's going to do a project. I'd be just as happy to not have to grade any finals. So, if that's true, then you're not going to have to worry about it. But, the final exam, if you're going to take it, will open on the 11th and close on the 17th. Right? And so, how many lectures do we have left? We've got 2 more lectures. We've got one on Thursday, and we've got one coming up on Tuesday. And I'm not going to assign homework on the idea of inheritance, because I want y'all to be working on your projects. Did we do an assignment over properties, though? Remind me. Simon, did we do homework over properties?
Say no.
So our last homework did properties. So I'm happy with that. If you haven't done that homework and you want to implement them as auto properties, like the textbook showed and like I did, then you can, right? You just have to add the curly brace and a get and a set, and then you don't even need to do this part. But if you're going to follow the homework explicitly, you know, I'll give you credit either way. Make the private variables and then the public properties that expose those, that reflect them. All right, and so I'm comfortable not giving homework over inheritance, so let's just end the lecture and let you upload it.
Okay, I've been.
Then I'll help with typing.